Okay, I have a couple of quiz problems. Started with this one, then I decided, well, this is a little easier. Some people might want to start with this one. Everybody did pretty well with these, completely well. But there were a few little glitches, so let's just start with easier problem. We got x equals m y minus r. We're trying to solve for r. Well, a couple of ways we can go about this. But I'll just put an underline under R to indicate that's what we're solving for. If we get rid of that my, then R is going to be isolated on this side. So we could do this. We can add negative my to both sides. And we do that by adding original equation to the equation, negative my equals negative my. So just write down negative my here and negative my there. If you do, you're going to be vulnerable to some really bonehead errors that people make. Okay? And don't be insulted by the word bonehead because you see me make them. And it's one of my favorite self-descriptions. Okay. So when you put that together, you get x minus my, and you're going to get negative r, but I like to tell you to go ahead and write down everything. So you write down my minus r minus my. And then you look at this, not this. You got my minus my, that gives you negative r. You got x minus my. And we've almost got it, but this is negative r, okay? So we'd like to see r on the left. I'm just going to rewrite this, switch the two sides. And now I just multiply negative r by negative 1. And negative 1 times negative r gives me r. And then I've got to multiply the entire other side by negative 1. Negative 1 times x gives me negative x. Negative 1 times my gives me my. And you could, if you want, write that r equals my minus x. It could be written in either order. Okay? Want to solve this for y? Same equation. First, we're going to add r to both sides. So we get x plus r equals my minus r plus r. And the minus r plus r gives us just my. And here we get x plus r. And now all we've got to do is divide both sides by m, and we're going to have this plain y. We'll get a solution for y. First, I'm going to write this my equals x plus r, just so the y is going to end up on the left, which is kind of where we're more comfortable seeing it. It's not wrong if it's on the right, but it's just somehow grammatically a little more friendly if we put it on the left. And everybody knows this step. We're going to divide both sides by m. The m here is going to divide the m here and give us 1. And we get y equals x plus r for m. So it's fairly straightforward. Okay, now over here, there's a little bit of complication because you've got distributive law. So we got big A equals little a times b plus c. And we want to solve for little a. Now, the first impulse, and it's a good natural impulse, would be to use a distributive law, right? This is AB plus AC. And there's nothing wrong with that, except it's a little more efficient if you simply divide both sides by B plus C. And the B plus C in the denominator matches the b plus c in the numerator. So they will divide out, and you're going to end up with a, little a, equals big A over b plus c. Now I went ahead and reversed sides. I'm going to get little a on this side and get big A over b plus c on the left side. Okay. Now I realize that I'm not saying this in an ADA compliant way, so I'm going to say it quickly in an ADA compliant way. I've got to read everything, okay? I've got to get myself in the habit of that. So we start with the equation x equals my minus r. We're solving for r. So we write down our equation, and we notice that r is all by itself over here on the right-hand side. So the right-hand side reads my minus r. We subtract my from both sides, and we're going to get what? On the left-hand side, we have x, and we're going to subtract my, so we get x minus my. On the right-hand side, we've got my minus r. When we subtract my, we get my minus r minus my. Well, the my minus my gives us 0, leaving us just negative r. So we have negative r equals x minus my. We still have to find r, not negative r, but that's easy. If we multiply negative r by negative 1, we're going to get r. Of course, we want to multiply negative r by negative 1. We better multiply both sides by negative 1. So we do negative 1 times negative r equals negative 1 times the quantity x minus my, the quantity. Giving us then negative 1 times negative r is r, negative 1 times the quantity x minus my by the distributive law gives us negative x plus my. So r equals negative x plus my. Solving the same equation for y, we have, again, x equals my minus r. We add r to both sides because we want to isolate the y. If we add r to both sides, the r on the right side will go away and it'll leave us just my. So we add r to both sides, we get x plus r equals my minus r plus r. And minus r plus r is 0. So the right-hand side becomes just my. Left-hand side is x plus r. And now we have my equal to x plus r. We're going to divide both sides by m. My divided by m equals x plus r divided by m. And we have then y equals x plus r divided by m, because the m in the denominator of the left-hand side divides the m in the numerator on the left-hand side. Now we're solving the equation a equals little a, big A equals little a times the quantity b plus c. So we write the equation and we see that we can isolate a simply by dividing both sides by b plus c. So we write the equation down. Big A over b plus c equals little a over times b plus c over b plus c. On the right side, the b plus c in the denominator divides the b plus c in the numerator, leaving us little a equals big A over b plus c. Now we want to solve the same equation. Big A equals little a times the quantity b plus c. And we want to solve this equation for c. Now, many people in the previous problem where we were solving for a wanted to do the distributive law first. That's not a bad instinct. Okay? But it's going to complicate the solution a lot because you're going to then have to factor the a out, and it's already factored out. Okay, well, whether you understand that or not, in the case of solving this equation for c, we are going to have to use the distributive law. So we're going to get big A equals little a times b plus little a times c. Now we've got c where we can get to it. we're going to subtract AB from both sides because the right-hand side is AB plus AC. We subtract AB from both sides, we'll just have AC. And we're getting closer to isolating C. So what we get without writing out all the details, we're going to get A, big A minus AB. That's big A minus little a times B equals AC. And then we're going to divide both sides of that equation by A, and that will isolate C on the right-hand side because we have AC. Divide by A, we're going to be left with C. So I'm going to write the equation as AC over A equals big A minus AB over A. And let's be clear, when I'm saying just plain old AB, I mean little a and little b. If I'm using capital letters, I'll say capital. Okay, so by default, letters are lowercase, but we distinguish because we have a big A and a little a, they stand for completely different things. Okay, they're separate variables. We want to make that clear. It should be clear to start with, but just to be sure. Okay, now left-hand side's AC over A. Well, the A in the denominator divides the A in the numerator, leaving it C. And then the right-hand side is just, again, big A minus AB, all that divided by A. Now, people will do bad things here. They'll see this and they'll cancel out the two A's on the right-hand side. You can't do that. You can cancel a factor of the denominator with a factor of the numerator. A factor is something that's multiplied by everything else in the numerator, and little a in the numerator, in the AB, is not multiplied in any way by the big A in the numerator. So you can't just selectively divide out the A's here. It looks like you ought to, and everybody goes by what it looks like rather than by the rules. And when I say that, everybody, I say 75% of the people coming into a pre-calculus class who should know better, but their curriculum hasn't prepared them to know better. And their work habits haven't, and they still get their grades. So we're in that situation, and we have to deal with it, and we have to talk about a lot of things that we should be able to see. Okay? So cancellation is one of the big things that I don't like to even mention. I talk about a factor of the denominator dividing a factor of the numerator. So don't be tempted to cancel anything. If you see like factors in denominator and numerator, this is multiplied by the whole denominator, and this is the same thing as multiplied by the whole rest of the numerator, then you can divide them out. Okay. And if you can do these two problems, and everybody either got these or did a lot of right things, okay? So that was good to see. But there were still a few little wrong turns. It's really easy to make a wrong turn. So you want to practice until you're sure you've got it right. Okay, well, a couple of things that we need to talk about, and let me pause for a second. Okay, now I wanted to double check our calendar to make sure we're talking about all the right things. I'm teaching a bunch of very similar courses. So, I mean, the courses themselves aren't similar, but a lot of the topics are similar. So if I did things yesterday in a class that's doing something that we're doing today, it's like I've said it here, okay? So I've got to keep myself on track there. And I find there are actually 3 sections that I want to assign this weekend. On linear inequalities, which are very easy. They're just like equations. There's just one rule you got to remember. And then you want to be able to draw a picture to indicate the solutions. And absolute values and then an introduction to graphing, like graphing on a set of XY coordinates. These are things, the graphing on a set of XY coordinates is something that people generally don't have much trouble with because everybody's seen it. But if you haven't, throw something at me and say, slow down. Okay. Okay. Because we can do that. Um, so okay, now I'm going to make a mistake. Okay. So intentional error upcoming. Okay, I'm going to take the equation 2x plus 8 less than 4x plus 16. Okay. Now I'm going to treat this less than just as if it was an equal sign. And you can do that a lot of the time, but there are times when you can't. This is going to be one of the times when you can't, but I'm going to go ahead and treat it like an equal sign until I check and find out that my solution is wrong. Okay? So, first of all, I subtract 4x from both sides. And, you can do this as long as you use an equal sign. You can do minus 4x here, and you can do minus 4x here if you like. And you get 2x plus 8 minus 4x less than, because the left-hand side is less than the right-hand side. In the equation I just wrote, negative 4x equals negative 4x. The left and right-hand sides are identical. So if I add the same thing to two other things, and one of them is less than the other, well, when I add, that thing is still going to be less than the other, okay? If I add the same thing, something on my right that's less than something on my left, what I end up with on my right is going to be still less than what I end up on my left. What I end up with on my left, okay? So we're going to then have 4x plus 16 minus 4x. Then we simplify. 4x minus 4x is 0. So on the right-hand side, we just have 16. On the left-hand side, 2x minus 4x is negative 2x. And we'll still have the plus 8. But we combined the 2x and negative 4x. Okay? Well, now let's subtract 8. In other words, add negative 8 to both sides. I write the equation negative 8 equals negative 8 and add the two equations to give me negative 2x plus 8 minus 8 equals, less than 16 minus 8. And we can see clearly then that on the left, the 8 minus 8 gives us 0, leaves us with negative 2x. 16 minus 8 is 8. And now I simply divide both sides by negative 2. I'm going to do it wrong. Then we're going to see why it's wrong. Okay, so I just go ahead and divide both sides by negative 2, and I get negative 2x over 2 less than 8 over negative 2. And that clearly simplifies to x less than negative 4. Okay? Now, let's check. Pick an x that's less than negative 4. Pause it. camera here. Let everybody tell me their favorite number is less than negative. Okay, everybody wants to use -5. That's a pretty obvious choice. As I said, I was going to use -793, but I'll bow to the wisdom of the class. Okay. Okay, if x is -5, is this a true statement? Plug that in to the equation. So call it an equation, it's an inequality. Plug -5 into the original inequality. We have 2x plus 8 less than 4x plus 16. If we plug x equals -5, we get 2 times -5 plus 8 less than 4 times -5 plus 16. Okay, well, we can evaluate those numbers. We get -10 plus 8 on the left, and on the right, we get -20 plus 16. -10 plus 8 is -2, and -20 plus 16 is -4. So if we plug -5 into the original equation and evaluate everything, we get -2 is less than -4. Now, it probably looks wrong to most of you, but let's make sure we understand why it's wrong. Okay, so on the number line, if -2 is here, then is -4 here? No, -4 is to the left of -2. Okay. So, if you're visually impaired, you should simply understand that 2 degrees below zero is warmer than 4 degrees below zero. Okay. If you lose $2, it's better than losing $4. Okay. A lot of ways to think of that. Okay. So, you see that we have a bad solution. Where does the solution go bad? You can't argue with anything down to this point unless I made a bonehead error in arithmetic, because I'm simply adding the same quantity to both sides of an inequality. That's not going to change the direction of the inequality. Okay. However, when I divide by a negative, it does change the direction of the inequality. So when I got -2x over -2, well, I started with -2x less than 8. Divided by 2, I had -2x over -2 less than 8 over -2. That's where I made the intentional error. When you divide or multiply by a negative number, the inequality switches direction. So that step should have been -2x over -2 is greater than 8 over -2. So that x is greater than -4. So that's very simple. You just have to remember to do it. You just have to remember if you multiply or divide by a negative quantity, you've got to reverse the inequality. So now if we let like x equal -2 and plug in, 2x plus 8 will become 4. You can do that yourself. 2 times -2 plus 8 gives you 4. And 4 times -2 plus 16 equals 8. Okay? And 4 is less than 8. So the inequality is satisfied if x equals -2. So we know now which side of the x equals -4 point satisfies this equation. And we graph that solution. Okay, x equals -4 is the point at which the inequality goes from false to true. X is less than -4, as it was with -5. We find that the equation is false. So on the x-axis, at the point where x equals -4, I draw a little circle. That circle surrounds the point. And I don't fill in the circle. I just draw the circle, and then I draw an arrow starting at the middle of that circle and moving to the right, meaning every x value on this side of -4 satisfies the equation or the inequality. If the inequality had been less than or equal, then I'd have gotten less than or equal signs all the way down here. And when I reversed it, I'd get a greater than or equal sign. Now, I don't have a less than or equal sign in the original, so I'm not going to have a greater than or equal sign in the final. But if I do have a greater than or equal sign, that little circle that I drew needs to be filled in to indicate that x equals -4 is a solution. Okay? It isn't a solution here because -4 is not greater than itself, it's equal to itself. Okay. Now that's all I'm going to tell you about inequalities, because I think from what I'm seeing that you all are going to be just fine. And if you aren't, we'll address any errors that I see in your homework, okay? Or any questions that you have on class. And they will throw a couple little curveballs at you. I want to see if you can deal with those curveballs. Good for your soul. Okay. There aren't that many of them. I don't think anybody's going to have any trouble doing well on that part of the homework. All right. Next thing I want to talk about is absolute values. First of all, just intuitively, is everybody familiar with absolute value signs? Okay. The absolute value of 5 is 5. The absolute value of -5 is 5. Okay. The absolute value of a number could be visualized as, okay, here's 0. Here's 5. Here's -5. -5 and 5 are the same distance. Probably can't read it now. It says same distance from 0. I simply drawn a line for the x-axis. Then I drew a little horizontal line. It could be a tick mark, but I did a vertical line, little vertical line, and labeled that 0. And then at equal distance on the right and left, I did a couple little vertical lines through my horizontal line and called those -5 and 5. And I've got a couple of arrows indicating the distance between 0 and each of those points, and they're clearly at the same distance. So the absolute value of a quantity is its distance from 0. It's one way to think of it, and that can be a profitable way to think about it. Another way of saying it is the absolute value of x equals x if x is greater than 0 or equal to 0, and it's equal to negative x less than 0. So there are two possible ways you calculate the value of the absolute value of x. For example, the absolute value of 5, well, 5 is greater than or equal to 0, so you're going to get 5, right? The absolute value of negative 5, well, if x is negative 5, x is less than 0, so the absolute value is going to be negative x. What's the negative of negative 5? Well, two negatives make a positive, right? So you're going to see that, and that can be an important definition, but a lot of times just the intuitive definition suffices. But when you need the official definition, which is what I've written here, equals x if x is greater than or equal to 0, equals negative x if x is less than 0. That official definition is necessary sometimes when you're dealing with symbols, especially. If you're just dealing with straight numbers, not so much. Now, can you tell me if I have the equation absolute value of x equals 12? Can you give me, let me write a different number. Let me make it 7. Now you can show me with your fingers. Can you give me a value of x that makes that true? Okay. Yeah, 7. I'm not sure what you were doing with that hand, but a lot of dexterity there, but you got it. Okay. I admire you. I've got a couple of trigger fingers that are a bit, yeah, occasionally a pain. They're getting a little better. So hopefully they'll go away. I mean, fingers will stay, but the trigger thing will go away. Okay. Okay. Well, is there another value of x other than 7? Okay. Now what I've done, the equation is absolute value of x equals 7. Obviously now if x equals 7, that equation is satisfied because the absolute value of 7 is 7. What's another value? Negative 7, right? And you could indicate that with your fingers. Or stand on your head. And no, you don't want to do that. Okay. All right, the solution's this way. And for future use, it's but what this equation, absolute value of x minus 3 equals 5, is telling you and is requiring, and what in the world happened to my Zoom window? I think it's still working. All of a sudden, the window just minimized itself. I was looking really small and I was getting worried about myself. Okay, absolute value of x minus 3 equals 5. What does this equation saying? It's saying that whatever the absolute value of x minus 3 is, and you don't know what it is, okay? whatever the absolute value of x minus 3 is, or whatever x minus 3 is, it's got to be either 5 or negative 5, doesn't it? If the absolute value of something equals 5, then that something has to either equal 5 or negative 5. So it's very easy to solve this equation if you just remember that whatever's in the absolute value sign, which in this case is x minus 3, could equal 5, or it could equal negative 5. Okay? You cannot, you may, but you really cannot argue with the logic of what I said, because all I said is something inside absolute value signs equals 5. I know that whatever's inside those absolute value signs has to either be negative 5 or 5. So here's what we get. And then we solve. I'm not going to write out all the steps here, because everybody can add 3 to both sides of this equation, get negative 2. Everybody can add 3 to the two sides of the equation, x minus 3 equals 5, and get 2, and add 3 to both sides of, I put negative 5 on both sides, okay? Again, x minus 3 equals negative 5, or x minus 3 equals 5. Take the x minus 3 equals 5 equation, add 3 to both sides, we get x equals 8. Now, coincidentally, if I have negative 2 here, have eight here. Now what I've done, I've just drawn a horizontal line, a number line, and then a little vertical line for x equals negative 2, a little vertical line for x equals 8. What's halfway between negative 2 and 8? You show me the figures. How do you get a number halfway between two numbers? Add them and divide by 2. That's how you get a mean average, okay? Add two numbers and divide by 2, you get the number that's in the middle. If you didn't know that before, sue your school system, or sue the publisher of the textbook, sue whoever designed the curriculum. It wasn't your school system, okay? Because it's a terrible, terrible omission. But a lot of people don't seem to know that. Well, if I had negative 2 and 8, I get 6. Divide by 2, I get 3. Okay? Now, how far is it between 3 and 8? And how far is it between negative 2 and 8? 5 each way. Okay? Now, what I've just drawn is I've drawn a two-headed arrow between x equals 3 and x equals 8, and a two-headed arrow between x equals 3 and x equals negative 2. The two-headed arrow means I'm not concerned about what direction we're moving. I'm just concerned with how far it is. Okay? So how far it is in both cases is 5, and how far it is, of course, is the absolute value of the displacement, and don't worry about that. Okay. Now, what this is showing you is a picture of this inequality. Okay. This inequality says the absolute value of x minus 3 equals 5. Okay. 3 is in the middle. The absolute value of x minus 3 is how far you are from negative 3. And we see that that's 5, just as in the equation. Now it gets more complicated. We can have an equation like absolute value of 4 plus 2 equals 12. Okay? Now, you don't yet know how to solve that equation, the equation you're going to get, but you do know what the first step is going to be. The first step is going to be you write 4x squared minus 7x plus 2 equals 12. You put an or between that. Then you put a 4x squared minus 7x plus 2. I've been doing the negative. Okay, on the first one, I'll use 4x squared minus 7x plus 2 equals negative 12, or 4x squared minus 7x plus 2 equals 12. Doesn't really matter which one's negative and which one's positive, but I've been doing the negative first, so I'm going to be consistent. Okay. And now you have to know how to solve these equations. It's not particularly difficult to learn to solve those equations. Use the quadratic formula. That's just bookkeeper. Okay. There's more about it, but quadratic formula will get you the solution. And you'll find out that there's no real solution. There's no number you can put in here to give you 12. That comes up later. Now, there are absolute value inequalities. So let's take this equation, absolute value of x minus 3 equals 5. Again, but now I'm going to make it into an inequality. Absolute value of x minus 3 is less than 5. Okay? Now this means that the distance of x from 3 is less than 5. Okay? Now we already know what absolute value of x minus 3 equals 5 looks like. The solutions are x equals negative 2 and x equals 8, with x equals 3 in the middle. Now, if the absolute value of x minus 3 is less than 5, that means x has to be closer to 3 than it was for absolute value of x minus 3 equals 5. Don't really like that last sentence I just said, but it means that the distance of x from 3 is less than 5. We can even draw a picture. We can put x equals 3 on a number line in the middle, and we can put x equals 8 on the right, and we can put x equals negative 2 on the left. Same numbers that we got previously. The solution is the part of the number line that's between negative 2 and 8. If you're between negative 2 and 8, then you're within 5 units of 3. It's easy to see if you can draw it, but you can also imagine it. So that my solution looks like this. And what I've drawn is simply a circle around the x equals negative 2 point, a circle around the x equals 8 point. I've got the x equals 3 point marked in the middle. And then I've just drawn a line segment from one circle to the other. And that indicates all the values of x that are closer to 3 than 8. Now, I talked about logic. I talked about using this or here, right? Okay, there's ors and ands involved here. An absolute value of x minus 3 less than 5 means minus 3 is less than 5, and x minus 3 is greater than negative 5. Solving these two equations, this tells you that x is less than 8 and x is greater than negative 2. The picture that I drew, this solution ran from x equals negative 2 to x equals 8, everything between negative 2 and 8. Now, if x is less than 8, well, I can draw a picture of x less than 8. Here's 8 on the number line. And I'll just draw a little circle around 8. An arrow a little bit under the number line, all the way to the left. That's the inequality x less than 8. Then I'm going to draw x greater than negative 2. And I'm going to use a little different color when I draw. But we understand that I just put a little circle around the x equals negative 2. Let's see, this is x equals 8. And I draw an arrow to the right. It's a little bit above the number line, but it goes all the way to the right. It goes from x equals negative 2 all the way past x equals 8, all the way out to x equals 5 zillion and beyond. Okay? And the first arrow I drew, again, started at x equals 8, went to the left, past x equals negative 2, and kept going forever. Okay? Now, where are the values of x that are both less than 8 and greater than negative 2? The values of x that are less than 8, again, start at 8, go to the left, past x equals negative 2 and forever. But as soon as we get past x equals negative 2, the x greater than negative 2 condition isn't satisfied anymore, right? If we have both x less than 8 and x greater than negative 2, that only occurs between 2 and 8. The parts of the arrows that go to the right past 8 and the part of the arrow that goes to the left past negative 2 don't satisfy x less than 8 and x greater than negative 2. Satisfies is where those two arrows intersect. The use of the word intersection. The intersection of two things is where they both are. Okay? This arrow intersects this arrow. The arrow to the right intersects the arrow to the left on the interval between negative 2 and 8. That's a way of visualizing. But of course, if you're vision impaired or just not very good at visualizing, we have the rule. It's got to be less than 8 and greater than -2. And we can write that as -2 less than 8, -2 less than x less than 8. There's another case. Okay. What if we want the absolute value of x minus 3 greater than 5? Means x is more than 5 units. Three. Well, we can already draw that. We draw a horizontal number line. We label one of the points x equals 3. And then to the right, we label a point x equals 8. And to the left, a point x equals -2, because 5 units from 3 gives us 8. If we go to the right, 5 units to the left of 3 is going to give us -2. Now what we have is all the points that are more than 5 units away. So we draw a little open circle at x equals 8 because we have to be more than 5 units. So 8 is 5 units, it's not more. So we do an open circle and then an arrow going to the right. You can see or visualize that all the points on this arrow are more than 5 units. 3. If you want to just do that with your hands, you put your hands together right there as x equals 3. Move each hand 5 units. Everything between your hands is within 5 units of 3. Everything beyond your hands is greater than 5 units from 3. So the way we solution of absolute value of x minus 3 greater than 5 is x minus 3 say is greater than 5, or x minus 3 is less than -5. Which means if I solve x minus 3 greater than 5, it's obvious that the solution is x is greater than 8. I put an or in here. And then I solve x minus 3 less than -5. Add 3 to both sides. I get x less than -2. That exactly matches my picture, my experience of 3 being in the middle. Move the hands 5 units, each hand 5 units from 3. In the places where x minus 3 is greater than 5, outside the region between my hands. Or the picture that we see on the board, if we can see it. It's got to be or. I can't say x is greater than 8 and x is less than -2. Can you give me an x that's greater than 8 and less than -2? No, if you give me an x that's greater than 8, it's not less than -2. Okay? If you give me an x less than -2, it's not greater than 8. That logic is important, and I really want to see that when you write these out. There are other places where you need to build on that logic, and you want to think about what that means. Okay? Uh, on a test, I would probably accept. Well, actually, in this case, you need the or. Okay? In this, if you got an absolute value greater than something, you need to say or. If you have an absolute value less than something, you can shortcut that, but I prefer you use the and. Okay? You see, Open Math is going to show you can shortcut it. You can just say x minus 3 is less than 5 and greater than -5 and do a triple inequality. And you should be able to do that. But you need to understand where the and comes in here. All right. It's best if you understand where the and comes in. Okay, I'm going to give you just a brief introduction to graphing. I'm going to draw two vertical lines and label one x equals -2, the other x equals 8. And the -2 is going to be to the left of 8 because we consider right to be the positive direction. And I draw another line horizontal here for y equals 7. And then I want to draw a line for y equals 19. The two horizontal lines intersect the two vertical lines in 2 points. Each in 4 points. There are 4 points of intersection. I have a point here. On the left vertical line, on the lower horizontal line, I have a point. And that point satisfies x equals -2, and it also satisfies y equals 7. So I'm going to label that point -2, 7. Now, where the rightmost of the two lines intersects the lower of the horizontal lines, well, that's the rightmost vertical line is x equals 8, and the lower horizontal line is y equals 7. So we'll label that point 8, 7. Label the x coordinate first, then the y coordinate. These are called the coordinates of the point. Again, I imagine everybody's pretty familiar with this. Okay, then we go to the intersection of the upper line with the two horizontal lines. The x equals 2 line is the one to the left, and it intersects the upper line, the y equals 19 line, at a point that we call 219. The vertical line on the right is the x equals 8 line, and it intersects the higher of the two lines at y equals 19, and that point would therefore be 8, 19. And writing, -2, 7, I'm writing the left parenthesis, -2, comma, 7, right parenthesis. So we indicate these points by ordered pairs within parentheses with a comma between the x and the y coordinate. Okay. So other points read left parentheses, left parenthesis 8, comma 7, right parenthesis. Left parenthesis -2, comma 19, right parenthesis. And similarly for the fourth point. Well, a lot of the open math is just involved with locating points. They give you a grid. I don't like grids when you're introducing this stuff because people get dependent on grids and they can't draw a picture. And if they do draw a grid, they usually don't do a very good job of it. Okay. Also, the idea that x equals -2 is a vertical line. All the x values that are -2 are on a vertical line. All the x values where x equals 8 are on a vertical line. So we just say we have the line x equals -2, the line x equals 8. Okay? And similarly with the y lines. There's a reason for this brief introduction. Now, I'm assuming you have some familiarity with graphing. You're not going to be able to be asked to graph complicated functions in the open math assignment. Okay. So there are 3 assignments. They're due Friday, Saturday, and Sunday. You can do them as soon as you want to and have a good weekend. They shouldn't be extraordinarily time consuming. You get hung up on a problem, go to another problem, come back and finish it later. I always recommend that you start an assignment as early as possible when everything's still fresh in your mind and give it time to sink in case there's something you got to come back to. Everybody waits till the last minute, screws it up anywhere. Okay? So take my advice. You'll be the first to ever do it.